So now in this video we have a circuit where the LED gets dimmer as it gets darker out. So we'll move this over here. The lamp is not at its brightest setting right now. I thought it was. There we go. I brightened it. You can see we got more current. So the LED is getting dimmer, but you can't really tell because there's the light. But you can see when I darken it, it fades off right there. So we have the op amp wired as a voltage follower. So now when you wire an op amp as a voltage follower, in fact any circuit, the output is influenced by the voltages at the non-inverting input and the inverting input. But the output wants to be more like the non-inverting input than the inverting input. So what it does is it raises or lowers it. Since we have a negative feedback going directly from the output to the inverting input, it just gives you the exact same voltage. It's that simple. If this was a lower voltage, then it would raise the voltage. But in any case, it stops when it is at the voltage of the non-inverting input. Under bright light, the voltage goes up, and because we have a better connection there, so the LED is brighter. As it gets darker, the voltage goes down because this one starts being more influential. This gets higher resistance, it gets harder to go to the positive supply. So it pulls the voltage down, and at some point the LED will turn off. We could add a parallel resistor right there to set a minimum point where the LED won't get any dimmer, but I didn't add that to this circuit. And now we'll look at the circuit on the board. So of course you have to power the integrated circuit, positive to pin 8, negative to pin 4 right there. We're using 5 volts, and we have just this op amp being used right there. We're not using that one. So here is the plus, the non-inverting input. We have our light dependent resistor voltage divider right there. And we have above that the inverting input just tied directly to the output. So a negative there. So we got the output there. This is the same wiring. If we use this one, it wouldn't be a bad idea to put them to ground, tie them to a voltage, but I didn't do that. We shouldn't hurt anything anyways. So in any case, we got the output there and the LED. So long lead, the anode to the output, we're only using the one there. We could add another blue one, so when it got dark enough it got blue LED, but I decided not to in this video. Short lead cathode, 220 ohm resistor right there, because red LEDs are not terribly bright, even when they have almost 20 milliamps of current. So used a lower value resistor. So in any case, that's it.